Welcome to lecture number 53, Advanced Topics in Object Oriented Programming. So, in this lecture I will start with introduction to network programming, right. So, what do you mean by network programming? Suppose assume that you are writing a program which is communicating, assume that more than one device, right. So, two or more device precisely, right. So, you are writing a program so that we can communicate with several devices. In fact, nowadays it is happening, right. So, we have several chat devices or chat applications or even the web servers, right. So, we can able to communicate. So, the main objective is to establish and managing the connections, right. How to establish the connection, how we are going to manage the connection, that is the first objective, and then sending and receiving the data, right. So, you are sending the data, whether other person or even the group can able to receive the data, right, or they are sending the data, you are receiving the data, right. So, sending and receiving the data is a next objective, and the third one is we are ensuring the reliable and secure communication. So, whether you are getting the message from the reliable source and also when you are sending, how secure your message is, right. So, these are all the main key objectives in network programming, and day to day life we have several applications, right. Everyone is using web browsers, web servers, chat applications. So, nowadays it is very common, and even if you want to transfer a file, I mean you can able to do that, even making a video call, fine, right. So, you can do that. So, these are all the important applications, and other than this, so the IoT and distributed systems, Internet of Things and distributed systems, we have several applications, right. So, this is the basic introduction of network programming. So, now what do you mean by Open Systems Interconnection Model, OSI model, right. This is one of the standard questions, standard interview question. What are all the layers in OSI, right. So, we have 7 layers. The 7 layers go like this: application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer, right. So, the main purpose of OSI is to standardize the communication functions of a telecommunication or computing system. For example, if I take application layer, the user interface, you have HTTP and FTP, right, file transfer protocol, and the presentation layer. So, when you want to have a encryption or when you want to have a data formatting, right. So, we use the presentation layer, and then session layer is for session management, right, and the transport layer, the reliable data delivery, the TCP UDP, the reliable data delivery, and addressing and routing, you have a network layer, right, the IP address etc., network layer. So, you call it as a addressing, IP address, internet protocol address, data link layer. So, the frame delivery and error detection, right, if you want to find the error or if the error is being detected or the delivery of the frames, for this the data link layer is helpful, and the hardware and transmission media, physical layer. So, these are all the very important, and in fact the 7 layers, right. So, in fact it is a very common interview question, what are all the 7 layers that you know in OSI, right, OSI model, Open System Interconnection Model. So, first, what do you mean by sockets, right. So, sockets which are nothing but the endpoint communication. So, endpoint for communication between 2 machines, right. So, when you are having a 2 machines, so the endpoint for communication you call it as a socket. So, the key functions, let us say suppose I use socket, that will create a socket, right. Bind, we are going to use bind to an address and port, right, bind to an address and port. Another function is called listen, right, listen for incoming connections, accept a connection, initiate a connection, connect, right, you have accept a connection, listen for incoming connections, connect function is for initiate a connection, send or receive, right, you are sending and receiving a data, right. So, to send and receiving a data you have send or receive function, right. So, these are all the key functions, and what are all the different types of sockets. So, you have a TCP, right, which is for stream sockets, right, the stream sockets is for TCP, and the datagram sockets is for UDP, right. So, these are all some of the basics of the sockets. So, let us consider right, this first program in network programming, creating a simple server in C++, right. So, how we are going to create a simple server in C++? Let us have IO stream and C string, right. So, here you have sys/socket dot h, right. So, this contains socket related functions such as socket, bind and accept, just now we had seen, right. So, this header file contains socket, bind and accept. Another one is include net inet, right. So, the net inet, you have socket address underscore in, or it defines the structures and constants for internet domain addresses, right. So, the internet domain addresses, so which has a structures and constants. The last one is UNISTD, right. So, this provides close function to close file descriptors, right. So, this is useful for close function, right. In fact, it is providing the close function, right. So, which is for closing the file descriptors. So, with this we will go to the main program. So, in the main program you have an object server, in fact, it is a variable server underscore fd integer variable, right. So, the right hand side you have the socket function, you have af underscore inet. So, this is indicating the use of IPv4 internet protocol version 4, right. And then you have sock underscore stream, it is specifying TCP socket, right. So, this is specifying TCP socket, and then the 0. So, this uses the default protocol for TCP. So, 0 is for the default protocol for TCP, alright. And then, so whatever it is returning, that socket is returning, it will be stored in server underscore fd, which I already said, which is the integer variable, right. So, now line number 10 you have sock address underscore in, right. So, which is the object, under this object you have address. So, that address is initialized to 0. So, that means this is initializing the address structure which define the server's address and port, right. So, this is defining the server address and port, right. So, the next one is address is invoking the data member, right, SIN underscore family, right. So, which is AF underscore inet. So, this specifies the address family as IPv4, right. So, this specifies the address family as IPv4. So, the next line you have address is invoking SIN underscore address, which is invoking S underscore address, its address, right. So, the right hand side you have in address underscore any, right. So, what do you mean by this? So, this binds, right. So, this binds the socket to any IP address on the host machine. So, that is the meaning, right. So, this binds the socket to any IP address on the host machine. And line number 13 you have address SIN underscore port, right, HTONS of 8080, right. So, this sets the port number to 8080, right, sets the port number to 8080 and converting it to network byte order using HTONS, that means host to network short, right. The meaning of HTONS is nothing but host to network short, alright. So, this is happening over here. So, next come to the next line, that means line number 15 bind, right. So, here you have 3 parameters, one is server underscore fd, right, server underscore fd, and then the address, correct. So, here you have the reference of the address under the structure pointer sock address and then size of address, right. So, this binds a server socket, alright. So, this binds a server socket server underscore fd to the address and port specified in address, right. So, this is what this particular function is doing, right. So, you are passing server underscore fd and the reference of the address under the structure pointer sock address and the size of address. So, that means this binds the server underscore fd, right, to the address and port specified in address, that is what line number 15 is doing. Then line number 16 you have listen, you have two parameters server underscore fd comma 3. That means this puts the server in listening mode, allowing it to accept to 3 pending client connections, right. So, 3 pending client connections, right. So, 3 pending client connections. So, next one is a cout statement. So, that means this will be printed, server listening on port 8080 will be printed, right. So, a simple print message, and the next line client socket is a variable, integer variable, and on the right hand side you have accept function, this we had seen, right, accept, bind, etc., accept function. So, server underscore fd null pointer, right. So, here what it is happening, it is waiting for a client to connect and returns a new socket file descriptor, right, returns a new socket file descriptor which is called as the client underscore socket for the specific client connection, for the specific client connection, and then null pointer is passed for the client address and length, right, as they are not required here, right. So, this is up to your line number 19. So, now let us be in line number 20. So, line number 20 you have send function, all right, you are calling the send function. So, passing 3 parameters client socket, hello client 14, in fact 4 parameters and 0, right. So, it sends the string hello client to the connected client, right. So, 14 stands for length of the string, 14 stands for the length of the string, and 0. So, you can say that there is no special flags are used, no special flags are used, right. So, this is what your send function. Then you have close client socket. So, that closes the connection with the client, and line number 23 you have close server fd. So, that closes the server socket, and then you have return 0, right. So, when you run the code, right. So, here you are getting the output server listening on port 8080 will be printed, right. So, this is what happening over here, right. So, this is how you can create. So, this is the output we are getting. So, that means this is what, right, we are creating a simple server in C++, all right. So, this is what these are all the functions we use. So, first is for creating a socket that I explained, all right. So, which is for IP4 and IPv4 and TCP, correct. So, this is what we have done in line number 8, right. So, that is for, right. So, creating, right, socket, yeah, socket is in the right hand side, and bind the socket we use the bind function, and listen to connections I explain, right, listen. So, which is available in line number 16, bind is available in line number 15, right. So, then accept a connection, use accept, right. So, accept a connection we have used in line number 19, this also we have seen with the 3 parameters server underscore fd null pointer and null pointer, and send a message, right. So, we used to send a message using the send function. So, which is available in line number 20, right. So, and then close the socket, right. So, this is how you can create a simple server in C++. So, the next program we will see creating a simple client in C++, right. So, here we have included IOStream, right. So, IOStream and C string like a last program, and here we include sys/socket.h, right, the third header file. So, this provides socket related functions like socket, connect and read, right, and fourth one is arpa/inet. So, this contains the inet Python functions to convert IP address from text to binary form, right, IP addresses from text to binary form. So, inet/Python function, it is available in arpa/inet, and the next one is unistd.header file. So, which is providing the close function to close the socket, this we have already seen in the last program. So, now look at line number 8, we are coming to the main line number 8, you have client underscore ft, which is the integer, and like a last program socket af underscore inet, that is for IPv4, and sock underscore stream, which is indicating a TCP connection, right, and 0 which is representing the default protocol for TCP. So, the left hand side you have client underscore fd, which is used to refer the socket. Now, line number 10 you have sock address underscore in, and here you have server underscore address which is equal to singleton 0. So, this is representing, that means it is initializing the server underscore address, right, the server underscore address structure, right, the server underscore structure which stores the server's IP address and port, right. So, this is storing server's IP and right IP address and port. So, the next line you have server underscore address, right, dot SIN family which is equal to AF underscore INET. I already told this is specifying the address family as IPv4. So, the next line you have server underscore address dot SIN underscore port which is HTONS 8080. So, this we have already talked about this, right. So, this is setting the server port to 8080 and converts into network byte order using HTONs, right. So, this we had already seen. And next one INET underscore PTON, right. So, you have 3 parameters, one is AF underscore INET. So, that means your right 3 parameters, right now I am saying 3 parameters 1, 2 and 3, right. So, what exactly is happening? So, you have the loop back IP address. So, this is called the loop back IP address, right. So, that is 127.0.0.1 which you call it as a local host, right. So, from text to binary, right. So, this is converting the loop back IP address, right, 127.0.0.1 from text to binary and stores it in server, right. So, this binary form is being stored in the server, right, and in fact, it is storing it in server underscore address dot SIN underscore address. So, here it is being stored, right. So, converting and then it is being stored over here, right. So, the function, right, INET underscore PTON, so which is ensuring proper address formatting, either it will be IPv4 or IPv6, right. So, this is ensuring the proper address formatting, INET underscore PTON is ensuring the proper address format. Okay. So, either it will be IP4 or IPv6. So, now the next function connect, right. So, which we have already seen right in the previous program for the server client underscore FD, and then this is the address and the size of the address, right. And the next line, line number 6, in this we have already seen that whatever I have explained in the case of simple, right, creating a simple server. So, that will hold here also. So, line number 16 you have buffer of 1024, right, buffer of 1024 you are initializing to 0. So, the meaning is this is declaring a buffer size of 1024 to store the data received from the server, initializing all the elements to 0, right. It is initializing all the elements to 0, right, that is the meaning. And the next function you have read client FD buffer and 1024. So, that means it is reading up to 1024 bytes of data from the server into the buffer, right. So, here we have client underscore FD. So, that means the socket used for communication with the server, and you have buffer which stores the data received from the server, right. What about client underscore FD? So, the socket used for communication with the server, right. So, this is up to your read, and then you have a cout statement, server says. So, the buffer is right. So, that means whatever the data received from the server will be displayed, right, whatever the data received from the server will be displayed, and then close client underscore FD, right. So, this is closing, and then you are returning 0. So, when I run the code here you are seeing, right, server says that will be printed, and the buffer you are getting hello client, right. So, that means this is receiving this data, right. So, the data received from the server is hello client, right. So, data received from the server is hello client. So, that will be printed. So, because it is being stored over there, so that is being printed. Okay. So, this is what the output you are getting. Okay. So, these are all right the functions, the important functions we had seen, right. I explained about socket, for IPv4 and Internet Protocol version 4 and TCP, and I also talked about the SOC address underscore in, and we have also seen, right, the IP address is being converted into binary. So, inet underscore python is useful, and we have used the connect function and we read server's message, right. So, yeah, the read function we have used, and also for displaying a message, yeah, that is fine, cout, that is a standard one. Close the socket, we use the close function, right. All these we had seen. So, this is how we can able to create simple server and simple client using C++, right. So, the same code, in fact, I will run the code for Java, all right. So, the same whatever we had seen in C++, so we can do it in Java also, right. So, let us create a simple server in Java. So, whatever I talked about over there, which will be, right, to hold good in Java also. So, java.io utility star and java.net star, these utility is being used, and you have a public class server which is the driver class, and I have the main program. So, which throws IO exception, right. So, I have a server socket object, right, under the class server socket, right, because I have put all these utilities, and in the right hand side you have memory allocation with constructor by passing 8080, right. So, this is a similar code, right, what we had seen in C++, and you are printing one message, server listening to port 8080, and here you have client socket object, right, under socket, right, and in fact, the client socket is invoking accept, like the accept function that we had seen in C++. Similar to that, this will work over here, and here I have out, right, object. So, out object is under print writer. So, the constructor, after allocating a memory, dynamic memory, the constructor we are passing get output stream and the true value, all right. So, here you have a statement out.println hello client, right. So, then as usual the client socket is being closed and server socket is being closed. So, when you run the code, you will get the output, right, line number 7, server listening on port 8080 will be printed, right. So, whatever I explained in C++, I mean the similar to that, this will work in Java as well. So, now what we will do, we will run the code in Java, right. So, we will go to the Java compiler, and what we can do, we will run the code. So, let us create the simple client. So, this is what the output we are getting, server listening on port 8080, all right, server listening on port 8080, right. So, when you run the code, we are getting this particular output. So, here you have creating simple server.java, right. So, when I run the code, I am getting the output. So, we had seen how to create a simple server and simple client in both C++ and Java, and in the next class I will start from, right. So, the HTTP and REST basics. Thank you very much.